Okay, take 3. Let's try this once more. This is our first actual for real lesson, remote lesson with math being done from home. This is Calculus 2, online lesson number 1. The focus of this is going to be arc-trig integrals. We mostly covered this last time we met, 5 years ago, whenever that was. We just got about maybe 3 minutes worth of stuff to finish wrapping up, talk about there. Most of this lesson is going to be about L'Hopital's rule, which is an exciting throwback to limits and derivatives all at once. It's going to be a good time. Let's just go directly into this. I hope you're all feeling healthy and well. Let's make sure that I say that as well. So, arc-trig integrals. We talked about the integral of 1 over the square root of 1 minus x squared. We talked about how that was the arc sine of x. And we also talked about the integral of 1 over the square root of, I think, 4 minus x squared. And we decided that that should be what? We need to make x, in this case, we need to make x 2 sine of theta. And then dx is 2 cosine theta d theta. So this just turns into the arc sine of x over 2 plus c. This is what we did in class the last time we were together. So the one piece that we still need to do is arctans. And I will erase all this. Hopefully this is the last take I need to do. Don't need to rewrite all that for the beginning. Third time's a charm, right? So, the integral that we still need to talk about looks like the integral of 1 over 1 plus x squared dx. And I will just tell you for free, because I'm not super interested in doing all of the intricate steps. This is the arctan of x plus c. And you can discover this for yourself if you do this substitution where you set x equal to the tangent of theta. If you would like to finish this substitution to go from here to here, go for it. I approve this plan. Let me know how it goes. I'm not going to do that because I don't want to. I do want to talk about the integral of 4 plus x squared. Like we did with the arc sines, we changed up some of the numbers in them. We saw how that changed the integral. I want to do that for this as well. And 4 plus x squared is going to look like 4 times 1 plus x squared over 4. If you just factor a 4 out of these two things, this 4 is going to turn into a 1. This x squared is going to turn into x squared over 4, which is 1 over 4, 1 plus x over 2 squared. And then you can take this 4 on the outside as a 1/4. And now this you can do with u substitution into this, and you will get 1/2 arctan x over 2 plus c. So the big difference between the arctan and the arcsine here is that with the arcsine, you start messing with the number 4 in there to change the thing that was a 1. You get a different coefficient inside the arcsine. With an arctan, you get that coefficient on the inside and on the outside, which is kind of neat. That's everything I have to say about arctans. This section is really boring. It's pretty much just get the formula, use the formula, get points on your homework, and then you're good. So, I'm going to move right along to L'Hopital's rule. To do L'Hopital's rule, we're going to start by re-examining the idea of limits. If you have something like f of x equals, let's say, x squared minus 16 divided by x squared minus 2x minus 8. If you want the limit of f of x as x approaches, let's say, 3, you're going to hit this with plan A to get 3 squared minus 16 over 3 squared minus 2 times 3 minus 8, which should give you 9 minus 16 is negative 7. 9 minus 6 is 3, minus 8 is negative 5. So this will give you 7 fifths. And that's plan A. You just plug in the number. And if you want the limit of f of x as x approaches, let's say, positive 4. Is that right? Yeah. Let's say positive 4. We're going to try plan A. We're going to get 16 minus 16 on top. We're going to get 16 minus 8 on bottom, and we will have 0 over 0, which is no good. So then we go to plan B, where we simplify this and then try to plug it in after it's been simplified. This is x plus 4 times x minus 4. This is x plus 2 times x minus 4. That cancels. This leaves us with x plus 4 over x plus 2. So we're going to plan B this, and we'll get 4 plus 4 over 4 plus 2, and we will have 8 over 6, which is 4 thirds. So this is plan B. If plan A doesn't work, then you simplify the expression and try to plug it in. And then plan C, of course, if we want the limit of f of x as x approaches negative 2, plan A will give us 4 plus 4 minus 8 is 0 on the bottom, so plan A is going to fail. Plan B will give us negative 2 plus 2 is 0 on the bottom. Plan B is going to fail, so plan C is that this does not exist. I would have written down plan A and plan B, but this is a video. You can just rewind if you missed it, and I don't have space, so there we go. There's my gesture. I gotta work on being in frame. This is hard. So, this is our review of limits. This is how limits works. We have plan A, plan B, plan C. L'Hopital's rule is going to give us an alternate plan B. So let me talk about what that means. L'Hopital's rule says that if plan A results in an indeterminate form, then the limit, or then, yeah, the limit of, I'll say, top over bottom equals the limit of top prime over bottom prime. So let's talk about what this means. What is an indeterminate form? Indeterminate form means two things. 0 over 0 or infinity over infinity. Those are the only things that count as indeterminate. Those are the only times you can ever use L'Hopital's rule. Before, when we did limits, we said that you use plan B anytime plan A didn't work. This is much more discerning. Plan A has to fail in very specific ways for you to be allowed to use L'Hopital's rule. If you don't have an indeterminate form, you don't get to do this. If you get like some number divided by 0, it's not going to work. You can't use L'Hopital's. If you get infinity divided by some number or some number over infinity, it's also no good. It has to be 0 over 0 or infinity over infinity. Those are the only times L'Hopital's works. When L'Hopital's does work, what it allows you to do is you can just take the derivative of the top and the derivative of the bottom and then plug your number into those things instead. So instead of trying to simplify this whole thing out and figuring out how it's going to simplify, how it's going to, what factor or what else did we do in Calc 1? Rationalizing the denominator or multiplying by the conjugate. We did a lot of weird stuff for plan B in Calc 1. If we use L'Hopital's, you don't have to do any of that. You can just take derivatives of the top and bottom. So let's revisit the plan B situation that we just had up here. I asked for the limit of f of x as x approaches, what did I say? 4? Negative 4? Positive 4. Positive 4. The limit of f of x as x approaches positive 4. I really should script these things. So when we did this, we started with plan A, and that gave us 16 minus 16 divided by 16 minus 8 minus 8, which was 0 over 0. This is indeterminate. So we get to use L'Hopital's rule here. We need to take the derivative of the top. L'Hopital's rule says that we can take the limit as x approaches 4 of, derivative of the top is going to be 2x. Derivative of the bottom will be 2x minus 2. Now we have a new limit right here. We can just try to plug in our number. So we're kind of, once you use L'Hopital's and get your sort of like new version of this thing with its derivatives, you can just plug in these numbers. It's kind of like going back to plan A with this new version of the function. So if we just plug in these numbers, I'm going to call this plan A-ish, because plan A has already failed. This is the backup plan, I don't know. Plan A-ish. We can just plug in our number here. We get 8 over 8 minus 2, 8 over 6, which is 4 over 3, which is exactly what we got last time. So that's how you know it works. You're getting the same answers both ways. I want to talk about the former plan C situation from our last example. I wish this thing was bigger. You know. like having to erase things and then rewrite them. So, before, our plan C situation was the limit as x approaches -2, right? Yes. Of f of x. And we got, when we plan A'd this, we got, what, 4 minus 16, -12 over 0, which was no good. And then we plan B'd this. Actually, we don't even need to talk about plan B. What I want to talk about is, this is not indeterminate. So we cannot use L'Hopital's to get an alternate plan B here. When you get this thing, this is undefined. Which means L'Hopital's doesn't work. There's nothing we can do with this. We can go to the original plan B, where we factor it and we cancel things and we try to simplify. But L'Hopital's plan B cannot be applied. Either way, we're still going to end up in plan C. The limit does not exist. So that's how we do these guys. I'm going to cut the video here because I want these things to remain relatively short and quick. There are some interesting topics that we're going to get into with L'Hopital's, or not topics, interesting situations. For example, sometimes you have to use L'Hopital's a few times in a row. Sometimes after you take the derivative of the top and bottom and try your new plan A, you're still going to get an indeterminate form, and you need to take another derivative of the top and bottom. That is a possibility. You should look out for it. Sometimes you'll end up with something that looks like L'Hopital's, but it's undefined, and you cannot use L'Hopital's on things that are undefined. Only indeterminate. It's got to be indeterminate. So I feel like this is probably enough to get you started on the homework. Try a couple homework problems, see if you can get into the ones that have interesting situations, and we can talk about those in person on a video conference on Monday.